Welcome to the last video in this series of tutorial videos on how to write services for the IIP-Ecosphere platform. And this is just a question, what else is there what we didn't touch in these videos that you've seen before? Just some further topic. So it's about connectors. How do I approach an external machine or an external system? How to develop platform supplied services, just the ideas. What about the containers? How to distribute things to multiple machines if you have a complex application? How can you figure out at runtime that something is really operating? And what about the UI that we promised? In the examples that you walked through with Alexander, you did the ingestion of data, the data sources on your own. So for that purpose, you created a service acting as a source which emitted constant data, or might be random data, or read a file or whatever. If you go into a factory environment, you of course want to connect to a machine, to an actor, to a robot, to a sensor. And there you don't want to always do the protocol thingy with that respective machine on your own. For that purpose, we think that such types of services shall be generic platform supplied components that you can easily use in your applications. The core notion there is the connector, and in contrast to a service, it's a two-sided thing. So it on the one side connects to a machine, and on the other side it connects to an application. From the machine, data can be pushed through the connector using a certain protocol into the application. And on the other side, from the application, data can be fed back to the machine, for example, to change the configuration and the parameters of that machine. Such a connector typically realizes a protocol. That might be a protocol accessing an information model like OPC UA or asset administration shells, or it might directly use a pub/sub communication protocol like MQTT. Although these approaches are pretty much different and we are very well aware of that, we think that all these things can be unified into one notion of connector, and we can go even one step further. We can allow you to filter data already in the connector, that you don't push data into applications that you don't need. And we can even automate that for you. So in the end, the vision, and that's what the platform is realizing, is that you use these connectors like services, but you don't program them. How does this look like? In a configuration, it would look like that. You have something like a service, but it has a different type. Here it is OPC UA version 1 connector. You supply it with an ID. You supply it with the host and the port where the server is running. And yes, we can also do that ad hoc and dynamically if a device is providing us with that information. You can give it a sampling period. If the connector is not reacting on events, then this is the approach. You can provide it with security information, for example, to encrypt the communication with the respective server behind here for OPC UA. And then as for a service, you have in output going to the direction of the platform or coming from the applications. And you have two further specifications which address the external side, the machine, the ERP system, whatever, and this is the in and out interface. Here all the types that you see are just the same, which means the connector just pushes through the data that comes in. But there are additional goodies like field mappings, so you can tell the machinery which fields you want to have in a rather easy way. You can even start calculating with data in a connector. You can just specify that this field, for example, is a weight, and you don't want to use it in tons as the machine is doing. You want to go on in the application as kilos, and you just make a translation of the units there. You can do that without programming. A connector can do caching, which means it looks at the data before ingesting it, whether the last data point looks the same as these actual data point, and then it ingests only if there are differences. It can do mocking for testing, so you can supply it, as you have seen it by Alexander, with the JSON files for testing. And finally, and that's a new development, we even take into account the big OPC companion specs. For example, tobacco machines, which is one of the biggest. We turn this for you automatically from the OPC specification into our model specification. And if you use it, we generate the connector for you. And this is a lot of work behind. Well, as I said, a connector is a kind of generic service. There are also other services that are not connectors. These are then the generic services in general. Also, typically platform supplied, could also be from external side. For example, codec service, we had it in the additional platform examples, or the RapidMiner RTSA. The idea here is that the implementation of such services handles arbitrary data, in contrast to the services that you learned with Alexander, which were application-specific services. And they are specialized and customized into your application by code generation. For example, codecs to operate needs some files. And when we have the knowledge from the model, from the configuration model, we can generate these files for you and make this usable for you without any line of code. In the background, you have to do a lot of care in the configuration model, that you have to write the right type and provide it. You have to think about the integration by code generation. And finally, for such services, you have to write a kind of wrapper that it becomes a service of the platform. Basic wrappers are already provided. However, we didn't plan to go with you into the details of that, because as you have learned from Alexander, you would have to have background knowledge in IVML, VIL and VTL. So our offer is, if you created an application-specific service, which could be useful for others, just call us, we will help you. Finally, there is also specific care on IPR and licensing. Codecs, for example, is open source. RTSA is commercial software, and so you have to apply specific mechanisms to separate both, but to be able to integrate a full RTSA if you have a license for that. In the beginning, we quickly talked about containers. And containerization is not only a trend in Industry 4.0, it's actually also beneficial. On some devices, particular edge devices, you might not have the permissions to install anything. If the device is able to execute a container, it becomes easy because you can install Java and Python into a container and then it's running. And it's also beneficial to get rid of dependencies. Because if you installed an application with a certain set of dependencies and you want to get rid of this application or upgraded it, you might also want to get rid of these dependencies to don't have leftovers. A container can do this pretty nicely. Remove the container and replace it, and it's done. However, creating containers can be a tricky thing, because you have to have a lot of knowledge about the technologies that you need in the container, about the dependencies of services and packages that you have to install, partially down into system level dependencies. And so, if enabled, the platform instantiation creates these containers for you. Meaning the platform containers for controlling and the managing services of the platform, but also the application containers. And here in particular for Python services, we rely on the service dependencies that Alexander showed to you as an example, take them into account and create for you a container that is ready to run your application. Currently here we support Docker and LXC, and an integration of Kubernetes is in preparation and in experimentation. Now you might wonder, we have containers, we have services, applications and devices. How do I bring my services to a device, including potentially a container? This can become a rather complex task, and there we exploited the capability of the platform, which is called a deployment plan. You can configure such a deployment plan in the platform configuration, and here on the right side you see an excerpt how this looks like. So it has like a service, a name, an ID, a version and a description, but it points to the application it shall deploy, and for the application it makes a series of assignments which service goes to which device. In its simplest form, directly naming the identifier of the device here. You can also write these deployment plans on your own, but then you have to ensure consistency, mentioning all services using the right names. Or you can do it in the configuration by pointing to the right elements in the configuration to compose the right things. And also to know which containers to use or which artifact to use for the deployment, because this is implicit knowledge that we have in the configuration. Well, now you have your application successfully deployed. How do you figure out whether it's running as supposed? You can of course look at your outputs. You might have a dashboard there, and this is something that we plan to add to make the life also there easier. You can just also look into the platform monitoring, because all components of the platform are equipped with so-called meters, which deliver the basic resource information like CPU consumption, memory consumption, and things that like. And the generated services that are provided by the code generation during the integration phase also contain specific meters on service level. For example, how much data went in, how much data went out. And all this information is transported into the central platform monitoring, which is one option, Prometheus, an open source framework doing that nicely. On the right side, you see the user interface of Prometheus. It can cause alerts, and it allows you to look into the runtime operations of your application and your platform. Finally, one outlook on the platform management UI. It's already there, but it's still in development. On the one side, you can look, for example, into the resources, services, and deployment plans that you have on your platform deployed. Here on the left side, you see one device which is actually included in the platform as a resource. The information is taken from the asset administration shell of this device, or we can also create one for this device in a rather easy fashion, because asset administration shells are not everywhere at the moment. You can go into the deployment plans section. Here 3 example deployment plans that we used for one demonstration. And you just click on and say deploy my application, and it's doing that job for you. And if you want to get rid of it, you say undeploy and it's gone. And finally, and that's hopefully then the part that will ease your life with creating applications, we are currently creating an integrated application editor, which will allow you to make applications up in a drag and drop manner. And the hope is that you then have a button to get the implementation templates directly from the platform. You just work with them and deploy your solution into the platform and say, do my full integration of the application. There's much more information about the platform that you might be interested in, more information than we could put into videos. So basically, we have the platform handbook that not only explains you how to work with the platform, but also how it is designed and why are things done in the way we did it. There is the full code on GitHub with all documentation and additional information. And of course, there's the IIP-Ecosphere website, where you can just have a look on ongoing and further activities in IIP-Ecosphere in addition to the IIP-Ecosphere platform. That's it. That was the series of tutorial videos for creating services. Please stay tuned. For next month, dynamic demonstrators in IIP-Ecosphere will start, where external companies will provide services to the IIP-Ecosphere platform. We are about to create further features, as we explained to you, to make your life easier with that, and also further examples and evaluations in companies. And if you have any question, just let us know, as for the other topics that we discussed in these videos.